Susanna Brellis. I'm an environmental scientist at KCI Technologies, and we were contracted by Wicomico County Department of Public Works to do a watershed assessment of the Nanticoke River watershed. The primary goal of this watershed assessment was to identify pollutant sources in the watershed and to come up with a suite of BMPs to help with the water quality problems that we find. So in my presentation, first I'm going to go over some background, a bunch of maps about the watershed, and then I'm going to talk about the fieldwork that we did, which included a stream corridor assessment, and then an upland assessment, and then finally I'll talk about the recommendations that we came up with. So this was funded by a grant from MDE that Wicomico County Department of Public Works was granted, and KCI was contracted to do the study for them. And the county is going to be incorporating our recommendations into their work plan for their TMDL goals. So first, since our client was Wicomico County, we only looked at the Wicomico County portion of the Nanticoke River watershed. So whenever in this presentation I say the watershed, I'm only talking about this small portion of the watershed. So you can see this is the very downstream end of the Nanticoke River, and Dorchester County is on the west side, and Wicomico County is on the east side. Their portion of the watershed encompasses 130 square miles and includes many towns such as Ardella Springs, Nanticoke, and Sharptown. So some background land use information. The watershed is largely forested. There's 41% forest, which is great, followed by cropland, which is 28%, and wetlands make up a large portion at 9%. And then on the developed land use side, residential makes up the largest portion at 8% of the watershed. There's a lot of conservation easements. So this map shows color-coded the parcels that are under conservation easement by various easement holders. And 12%, I think, of the watershed is under conservation easement. So this is really awesome. There are 32 miles of the main stem Nanticoke in the Wicomico County portion. There are 192 miles of tributary streams in the watershed. And another fun fact is 66% of these streams have an intact 100-foot forest buffer. There's one Tier 2 stream segment in the watershed, the Plum Creek, up at the top northern portion of the watershed, and a Tier 2 stream is a designation from Maryland, the state of Maryland, that is a high-quality stream, and the catchments, which is in green, are under more strict water quality, anti-degradation rules, protection. There's another one, the Little Burnt Branch, is just outside of Nanticoke, outside of the watershed. And then there's lots of rare, threatened, and endangered species, too. There are 4 invertebrate animals, 3 vertebrates, and 48 plants. And this map on the right here in yellow shows the general areas of those species. Impervious area in the watershed is very low. It's 2.2%. And I don't know how many of you have seen this Center for Watershed Protection model, but they looked at the relationship between impervious cover in a watershed and the stream quality. And they found somewhere around 10%, anything above 10%, you start to see degradation in the stream. You start to see bank erosion and the biology affected. So 2.2 is, at the bottom there, so you're expected to see really good stream quality and good biology in a watershed with that low impervious area. And then Wicomico County maintains a database of their stormwater management that they have implemented. And so here it is color-coded on the map of the different types. The primary is wet ponds, and they also have some detention, dry ponds, infiltration, and grass swales. So moving on to the fieldwork portion that we did, the first part of it was the stream corridor assessments. We used DNR's methodology, which basically is to walk a stream reach, and we're taking GPS locations and photographs of various environmental features, which I have listed there. So we're looking for bank erosion, fish migration issues, channelization, trash dumping, and then we also added for the study a point for taking potential BMPs. So we did a desktop assessment to prioritize which stream reaches to go out to, because we wanted to be able to find issues and potential stream restoration sites. So we looked for streams with catchment areas that had higher impervious area and undertreated impervious surfaces. So these are the stream reaches we walked. It was about 8 miles. And I'm going to go through some of the features we picked up. So I'm used to working in highly urban watersheds, like in Howard County and Anne Arundel County, and bank erosion is usually a point we're taking over and over again. So I was very excited. We only found 2 sites in all 8 miles of the streams we walked. Partially that's because it's a coastal plain, lower gradient, generally has less erosion, but it was very exciting. Both of the sites were rated low severity. Inadequate stream buffers we saw quite a bit more. There was 20 sites total. We rated them as severe and low severity, primarily. It was mostly residential lawns and agriculture that we saw. We saw 2 fish barriers. They were both located at road crossings. This is one example. It was like a concrete structure that was damming up a large wetland, but there was, it was too high and too fast for a fish to be able to move upstream. But only 2 of those. Channelization, we saw 5 sites. Mostly they were ditches, like we've been talking about a lot today, old ag ditches and straightened channels, mostly low severity, if compared to like a channelized, like concrete channel that we're used to seeing as well. We saw 9 trash dumping sites, mostly residential trash, tires, old appliances, old rusty metal. Most of them were low severity. We didn't see any like hazardous waste drums or anything, but good opportunities for cleanups. Here's just a map of our inventory points, color-coded by the severity. And a table here. I just wanted to point out that most of what we saw was low and moderate severity. Most of the points, we picked up 51 total points. We also were looking for potential BMPs as we were walking around, and we located 4 tree planting sites and 1 possible pond retrofit that we sent engineers out to look at afterwards. And then at each reach, we took a representative point where we did a quick habitat assessment. So this is the results of that. In general, we saw good riparian vegetation, bank conditions, so the low erosion I was talking about, bank vegetation, lots of trees and shrub roots holding the banks together. So that was generally in the optimal conditions. And then we saw poor and marginal scores in the velocity depth, diversity, shelter for fish, and macroinvertebrate substrate, which is primarily because we were walking a lot of headwater streams that, were ditches primarily that just inherently don't have very good habitat. So as you move further downstream, you start to see those scores going up. So the next part is the upland assessment. We did a potential hotspot investigation and a neighborhood assessment, and we were using the Center for Watershed Protection's manual. So this is an example of the first page of the hotspot investigation, the types of data we were collecting. So first, the neighborhood source assessment that we did a desktop assessment where we looked at all the different types of neighborhoods in the watershed and kind of characterized them by lot size and development age. And then we visited 8 different neighborhoods, and we tried to get 1 representative neighborhood in each of those different types so that we could come up with a specific suite of BMPs for each neighborhood type. Typically, you have like townhouses, apartments, and single-family homes, and you're not going to recommend like a rain barrel, in an apartment. But a lot of these were the same sort of neighborhood, so they had a lot of similar recommendations. So here's some of the data that we collected. We looked at things like lawn management and fertilization use, impervious surfaces on lots, downspout locations, whether the downspouts were directed to impervious or pervious areas, whether there was tree canopy on the lots, and we looked at existing stormwater management facilities. And based on all that information, we made various recommendations for each watershed. So if there was space available in the lawns, we would recommend like basecaping or conservation landscaping or tree planting. And if there was room, we would recommend rain barrels or rain gardens. And we also looked at the BMPs in the neighborhoods to determine if there was any potential for retrofits or new BMPs. The hotspot investigation, we did a desktop assessment to look for commercial, institutional, and industrial kind of lots because those have a higher potential for stormwater pollutants and a good opportunity to install BMPs at those locations. And we didn't identify any actual hotspots, any issues, but we did come up with some good candidates for our engineers to go back out and visit to develop concept plans for stormwater management projects. So finally, the recommendations, we came up with 20 potential projects, and a team of engineers went out and looked at each of these to determine the feasibility. So they looked at things like construction access and utility access or utility constraints, and determine which BMP type would be appropriate at each site. So at the end of the fieldwork, they came up with 16 sites that were determined to be most feasible. And BMP types included shallow wetlands, wet ponds, bioretention, and sand filters. And also tree plantings and storm drain vacuuming. So then we ran those 16 projects through a project prioritization, which involved assessing each site on a variety of metrics, such as how much impervious surface they were going to be treating, the pollutant removal at each site, if there was potential problems with access or permitting or ownership. And so we're trying to figure out which projects were the best, had the best benefits. We also looked at cost, and also cost per impervious acre treated and cost per pollutant removal, so that we figured out which projects would give the county the best bang for the buck, which one would get the most impervious area treated for the least amount of money. So this is an example concept plan that we put together. Each concept plan is going to have any potential issues stated and any benefits. And we put together a little map with any structures. So then here's the 16 recommended projects ranked. So the projects on the top are the most beneficial and cost-effective relative to the entire set of projects. And if all of the projects are implemented, the total cost would be $1.8 million. And it would treat, in total, 44.8 impervious acres. And the reduction of nitrogen and phosphorus and sediment listed here would help the county achieve their Chesapeake Bay TMDO goals and improve local water quality in the Nanticoke River and its tributaries.
All right, well, thank you. My name's Matt Whitbeck. I'm a wildlife biologist at Blackwater National Wildlife Refuge. And the project I'm going to talk about for the next few minutes is essentially a marsh resiliency project, a tidal marsh resiliency project. So we've done a lot of projects in the past, primarily with the Army Corps of Engineers, where we've used dredged material to restore marsh in places where the marsh has converted to open water, either through sea level rise and subsidence or erosion. And we've done a lot of those projects very successfully. And so where this project is fundamentally different from those other use of dredged material to restore marsh is this was done a little more proactively. So we have areas of the refuge, large areas of the refuge, that are actively succumbing to sea level rise and subsidence, where the marshes are actively fragmenting, breaking up, and converting to open water. And so this project goes in and adds material to the surface of an existing marsh, building elevation, and hopefully building the resiliency of that marsh. And this project was done with funds from Hurricane Sandy resiliency through a National Fish and Wildlife Foundation grant to the Conservation Fund. And this project really is a partnership of the Conservation Fund, Audubon, Maryland, DC, and the Fish and Wildlife Service, and supported by a lot of other folks, the Army Corps of Engineers, USGS. A lot of people put a lot of time into making this happen. So just a little background here. Blackwater National Wildlife Refuge was established in 1933. It's one of the oldest refuges in the Atlantic Flyway. It's a little under 30,000 acres now, and very generally speaking, it's about 1/3 upland habitats, mostly forest, but we have some ag and grassland in there. About 1/3 tidal marsh and 1/3 open water. So I'm sure some of you have seen this these series of photographs before, but they tell an important story, so I'm including them. So this is a series of aerial images of the heart of the Blackwater River drainage, and you can see the photograph on the left. This was taken in 1938. You can see the well-defined river channel of the Blackwater and the Little Blackwater River, the confluence, and surrounded by a vast expanse of tidal marsh. This is the earliest photograph we could get, and we kind of consider it benchmark condition since the refuge was established in 33. And here's the same area in 1974. You can still kind of make out a shadow of those old river channels, but you can just see massive conversion of tidal marsh to open water. And then the same area in 1989, and you really have the formation of what we now lovingly call Lake Blackwater. It's just that broad expanse of open water that once was all tidal marsh. And so these days we just want to kind of step back for a second. These days we think about that marsh loss very much in the terms of sea level rise, subsidence, climate change. But it's important we don't lose sight that Nutria were a huge influence in driving that change that we saw in the landscape. And so Nutria is a non-native mammal from South America. It's superficially looks like a muskrat, but more the size of a beaver. And these critters are very good at essentially devouring the below ground plant parts and kind of rototilling that marsh and really accelerating that conversion to open water. Resource managers, on and around the refuge tried to deal with the Nutria problem the best they could over the years, but really didn't have that population level impact that we were looking for. So in 2002, we got funding from Congress to essentially initiate the Nutria eradication program. And the goal of this was to bring in USDA, Wildlife Services, to hire a bunch of technicians and go out there every day and eradicate Nutria. And it's been remarkably successful. Just on Blackwater alone, they estimated about 50,000 Nutria in 1998. And I've been here since 2008, and I haven't seen a Nutria in the wild since I got here. And I came from the Texas-Louisiana border. I know what Nutria look like. And actually, the technicians that are out there every day just celebrated 3 years without a Nutria detection. And it's incredible. I mean, so you think about just Blackwater having 50,000 in the late 90s and now functionally 0. So the trick now is just verifying that they are truly eradicated. Proving something doesn't exist is exceedingly difficult. You kind of think of Bigfoot. And so you go out there and you fail to detect it. Is it not there, or did you just not find it? That's the trick. So what everybody decided on is they will continue their survey efforts until December of 2020. And if they fail to detect a Nutria by that date, they're going to call it eradicated. Their base of operations was the Blackwater. That's where they started, but they work throughout the watersheds throughout the Delmarva Peninsula. So it's a tremendous thing. And really, and this sets the foundation for everything. We can't really, it doesn't make a lot of sense to spend money restoring marsh and enhancing marsh resiliency if you just have these critters coming up behind you and devouring everything that you're doing. And so, this eradication project really sets the foundation for everything moving forward. So the Nutria eradication is a huge success, and hopefully next time we have this conference, we can talk about the success of the Nutria eradication project. But so that dramatic change that we've seen on the landscape, one of the bright sides of all that marsh loss is that it drew the attention of a lot of wetland researchers. So folks with USGS and College of William and Mary and University of Maryland and Delaware, a lot of folks came down, and we've had grad student after grad student come through these marshes, and we know a lot about the factors that are driving the loss of the marsh on Blackwater. And to kind of sum up the key points here is the elevation of the existing marsh is low in the growth range for the plant. So these are all salt marsh tolerant plants. They're plants that are well adapted to the physiological rigors of life in a saline tidal environment. but they can only take so much depth and duration before they essentially drown and convert to open water. And the platform of the remaining marsh on Blackwater is low within the tide range. It's inundated for an excessive amount of time. And so even where we have the remaining marsh, small amounts of sea level rise and subsidence will continue to drive that conversion to open water. And the second thing is the marsh is building elevation and at a pretty good rate from what I understand, but it's not sufficient to keep pace with sea level rise and subsidence. So the eradication of Nutria is a huge first step. It'll undoubtedly slow that rate of change that we saw in those historic photographs, but we still have to contend with sea level rise and subsidence if the refuge and southern Dorchester County is going to continue to have the marshes that we have today and in the past. And this is what marsh loss looks like on Blackwater. It starts off very innocent looking. You have fragmentation and ponding within what kind of looks like a continuous marsh. Over time, as sea level rises and subsides, more plants drown. You get more and more open water. Then you get the formation of ponds. Over time, the adjacent ponds coalesce, and you just get these ever increasingly large bodies of open water. And so the idea of this thin layer project is essentially go in early in the process of fragmentation. So rather than wait for that marsh to convert to open water and have to add feet of material to restore that marsh platform, go in early in the process and add inches of material to put the elevation of that marsh into a place where the plants have a lot more vigorous growth and can be more resilient to sea level rise. And this is really based on a paper that was published in Ecology in 2012 by Matt Kerwin from William and Mary and Glenn Guttensbergen with USGS. This is a project they did on the refuge just a few hundred meters from the restoration site. And I stole a couple of figures here. And really the key outcome was this curve shows the below ground biomass production for some of our key marsh plants within our tide range. So if the elevation of the marsh platform is right around 30 centimeters NAVD88, that's the elevation of the marsh platform that really maximizes the health and vigor of these plants and maximizes the production of roots and rhizomes and all of the things that bulk up that soil profile and build elevation in the marsh. Unfortunately, 10 to 15 centimeters is right where a lot of our existing marsh is. So you can see we are right at the bottom of that growth range. So the idea of this project is to add material and push it from 10 to 15 centimeters to right around 30 centimeters. So you're putting the elevation of the marsh platform in a place where from the kind of a downward spiral at the bottom of the growth range to kind of the peak where it has the potential to build that below ground biomass and build elevation. So very simply, we took material from the inner meander bend of the Blackwater River and deposited it across the river over this 40-acre area. And for those of you that are familiar with Blackwater in this part of Dorchester, here's Maple Dam Road coming down. Here's the Shorter's Wharf over the Blackwater River and the public boat ramp Shorter's Wharf. So from the top of that bridge, you can get a pretty good look at the project site. So in December of 2016, we deposited about 26,000 cubic yards of material over about a 40-acre area. So generally, about Thanksgiving to Christmas of 2016, most of the pumping took place. So you can see the material coming out in a slurry and then just kind of depositing across the marsh and the kind of dewatering and settling out as it goes. And what was interesting about this project is when we were preparing for it, we spent a lot of time talking with neighbors and stakeholders and local elected officials, preparing them for what this is going to look like, right? Because to the uneducated eye, it just looked like a perfect piece of marsh. You know, it's got grass, it's good. You know, it's good. So if you don't look at the science and see what's going on, you don't understand that it's breaking up. So you take a perfectly good piece of marsh and you put 26,000 cubic yards of mud on top of it. It looks rough for a little while. And so we were preparing everybody for that, kind of that visual shock of it's going to look really rough before it gets better. But we were amazed at how fast this marsh recovered. So a lot of this marsh was dominated by Schonoplectus americanus, or three square, or only bulrush, depending on where you're from. And that is a cool season sedge. So what happened is we stopped pumping material in about December, and about March, when this cool season started to grow, the culms of these sedges shot up through that overlying material and reestablished themselves on the new marsh platform. So you can see the old marsh platform here, and those only eye culms just shot up and reestablished on that platform. So a large section of this project area greened up at the beginning of the growing season, just like it would have before. And that was made me feel much better. A lot of sleepless nights during the implementation of this. And then the areas that didn't passively revegetate, we went in and we planted about 250,000 2-inch plugs, mostly Spartina patens, but also some Disticulus bagata. And so here's just a series of photographs from the Shorter's Wharf Bridge. You can see pre-construction. Again, most of the materials deposited in December of 2016. So the top is immediately pre-construction. The middle one is just a few months after material was placed. You can see that 3 square coming up. And then the bottom one, October of 18, you can see much of that marsh is revegetated and looks very similar to what it did pre-construction. I only have a little bit of kind of results data to show everybody today. In January of 2018, we used a total station to get a topographic survey of the project. We surveyed about 32 acres, and of those 32 acres we surveyed, 25 acres had an elevation over 20 centimeters NAVD 88. And about 18 acres of those 32 had an elevation in that 24 to 34 centimeter range. So to kind of refresh our memory, this was the pre-construction elevation, 10 to 15 centimeters, and we were shooting for that about 30 centimeters. So about half of the project site got within that target area. Most of it benefited from some elevation enhancement, but about half of it got into that sweet spot we were shooting for. We were a little gun shy with this because the problems associated with exceeding your targets and Phragmites and all kinds of other things, we kind of erred on the side of caution and went a little lower, and that plays out in the data here. The birds responded very quickly. Seaside sparrows, Virginia rails, those were back and nesting that first growing season. Earlier this year, we found a black duck nest out on the site. Prior to construction, the marsh was way too low, too frequently flooded. You wouldn't have any black duck nests out there, so that was really encouraging. So the birds seem to be responding. And thankfully, there's a lot of people that have interest in this project. So a lot of people are ponying up to help us do some longer-term monitoring, which we typically don't have the resources to do. So we're working with Audubon, Maryland, DC to do vegetation and vegetation cover and composition. University of Delaware folks are doing breeding bird surveys, and Glenn Guttensbergen with USGS installed a whole series of surface elevation tables, or SETs, marker horizon plots, below ground biomass bags. So he's going to be able to see whether, how much we actually increase this elevation of this marsh, and whether we're changing the trajectory of that marsh elevation gain over time, and how much of that is attributable to below ground biomass production. So, yeah, so just touching on one more thing before I finish here. So I want to put this project in context. And so, the magnitude of marsh loss that we've experienced on Blackwater and really all over Dorchester County is huge, right? Over 5,000 acres just on Blackwater is converted from marsh to open water since the refuge was established in the 30s. So large scale. And so this project was fascinating, a great project, but it's still, 25 to 30 acres, depending on how far you stretch those numbers. And so we're not, trying to say that we're going to save the Blackwater marshes by thin layering, because that's just not feasible. But it is an important part of a much larger approach. So most of the marsh that's here in 100 years is going to be marsh that's been created through upslope migration, through marsh migration. So as sea level rises and land subsides, the same process that drowns existing marsh is creating new tidal wetlands and adjacent uplands. And so the sea level rise adaptation plan we did with the Conservation Fund in Audubon identifies these marsh migration corridors. Where are the largest expanses of tidal marsh likely to be in 2050 and 2100, and identified a series of strategies for protecting those corridors, and in some cases actually facilitating that marsh, that migration of marsh. So that's where most of the marsh is going to be. But that said, projects like this thin layer has application where it allows us to hang on to some of the highest priority marsh, and this is an example of one way to do that. And I think that's all I have. Yep. Thank you.